In this chapter, we're going to investigate graph theory. The first thing we're going to do is give you a vocabulary that helps you understand when we're talking about the graphs. We need to know that each of the dots, those are called vertices. If you have just one, it's called a vertex. All of the lines or possibly loops, those are called edges. An edge goes from one vertex to another, or sometimes to itself. If it goes from one vertex to itself, that's when it is called a loop. This is not a vertex here in the middle, okay, because we don't have a dot there. This is an edge. It just happens to be where the two edges cross. On the first example, they want you to understand the relationships in the graphs. They want you to explain why these two are equivalent. Now, they don't look the same, but if you just consider the vertices and the edges, they are the same. You have one line from A to B in both graphs, one line from B to C in both graphs, and one line from C to D in both graphs. So all the vertices are contained by the same edges here. They are connected, not contained, but connected by the same edges. That makes these equivalent. Now we use vertices and edges to figure out problems, especially when we're doing routing type problems. This is a modeling of Königsberg, I'm probably saying that wrong, which is a graph of Germany. Okay, so in the 1700s, they had this city in Germany. They noticed that it was located on the banks. So you had two banks here, then you had a river that split it, and you had two islands. They had bridges from the island, two that went to the right bank, two that went to the left bank. That's from this first island. Now the other island had a bridge to the first island, a bridge to the right bank, and a bridge to the left bank. So what we're going to do is we're going to model this using edges and vertices. So on the next slide, let's look at it. They called this island A and this one B. So we have an A here as a vertice, a B as a vertice. The right bank, that's a vertice called R. The left bank is a vertice called L. So we have all our vertices. Now we're going to represent our bridges. From island A, you have two bridges that go to the right bank. So they put both bridges. From island A, you have two bridges that go to the left bank. So they have their two bridges here. Also from island A, you have a bridge that goes across to island B here. Now the only other bridges we have left to put on our map are the bridges from B to R and B to L. So that would be these two. So if you ignore the waterway here, here is a graph that contains the vertices and the edges. We can also use this to model the relationship between the New England states. So here's a map of the New England states. We are going to let the states here, those are going to be vertices, and we're going to let their borders be edges. So let's draw this. So here we go. We have this. So they put VT for Vermont, ME for Maine, and so on. All the dots are our states. Now let's look. Maine only borders New Hampshire. So we're going to put one edge between Maine and New Hampshire. New Hampshire borders Vermont, Maine, and down here Massachusetts. So if we look from New Hampshire, we have a line to Vermont, a line to Maine, and a line to Massachusetts. Okay, now that's from New Hampshire. From Vermont, we have a line to New Hampshire, a line to Massachusetts here. So from New Hampshire, let me repeat that. We went from Vermont to Maine to Massachusetts. From Vermont, we can go to New Hampshire and Massachusetts. Now, we cannot go from Connecticut to Vermont or Rhode Island to Vermont, okay? We can only go from Connecticut and Rhode Island back to Maine. We can also go from Rhode Island to Connecticut itself. But Maine is in between those. You cannot go around them to get to the other. You have to go through. Oh, excuse me, I said Maine. I meant Massachusetts. Massachusetts is between them, okay? So you have to go through Massachusetts to be able to get to Vermont and New Hampshire.